So good afternoon. Thank you very much for the opportunity to discuss about Dessia technology. So at Dessia, we like to talk about augmented intelligence for two reasons. First, we use artificial intelligence, but also we use smart algorithms. So it's not about only artificial, it's about augmentation. In the end, whatever we develop with our tool, the human is in the loop, he's driving. It's not an autonomous software. So we are in the field of engineering, which is quite a complex environment. And there's a lot of engineering, of course, in aerospace and defense. So we were created in 2017. We got already two campaigns of fundraising where we had capital investors and also corporate investors that joined the Dessia. So we have French and German investors, and we are now 35 persons, all located in south of Paris. Most of my colleagues are very highly technical people, so we are really in a deep tech, let's say. So you see some names of industrial companies with which we are collaborating. Obviously, some aerospace, but not only. All what they have in common is they all design complex systems, and they challenge, or they have to challenge always their processes to be either more agile or more productive or more robust to compete on their own market. So the vision we have, of course, is AI, and we see it already happening at some of our clients. AI can really change the way you design products and the way you make decision, more enlightened or more informed decision for the next step of developing a product. The mission we have is developing a software platform that is there to industrialize AI in the engineering space. So what is specific with engineering? You have, of course, documents, PDF files. Of course, all the LLMs of the world, Mistral including, of course, can make very nice things for all about documents. But as you know, engineering, it's about 3D CAD geometry. It's about 2D technical drawings. It's about system engineering and so on. So if you want to apply AI on it, you have to develop some stacks specific to make it happen. So our platform is a web-based platform. It could be fully installed on premises, and this is what our clients are asking for. And it can be, of course, through APIs connected to different third-party tools, including the PLMs, which are the backbone of the data for engineering, for example. Practically, our solution is being used in two times. So on the left, this is the time where you develop your custom AI app, because this is the purpose of that platform. It starts with some libraries we have developed and we keep in developing. And those libraries are the foundation of any customized app. The customization happens in the way that the client will add its own knowledge. In engineering, we talk a lot about design rules, expert rules. You can also add your own data and specificities. So there is a small step in Python. This is our, let's say, foundational format, Python. But then quickly we emulate the Python code into a no-code environment with which you can build those apps. And then on the second time, on the right-hand side, this is where you use the app. You've got a kind of app store where the end users could be designer, architects, engineers, can just launch the app that will ask for necessary data to run. Of course, the platform itself is very much open and we can automate as well. It means that you can automate the full execution of Dessia in the background as a white mark, for example, from the PLM, if you want that your end users stay in their current space and don't go into a new tool. So now looking at some use cases very quickly, we see two kind of families of applications which are developed by our clients. All those applications based on AI, which is linked to how could I verify my designs. It happens that those industrial companies in that industry or others, they spend from 10 to 20% of their full time checking what they've designed, because this verification is done manually by humans per se. And so we propose here is that we can automate this execution of the verification. So the system will verify if it's in 3D, if there are some non-compliance with rules. And when it's in 2D, we'll verify the completeness of the blueprints, so checking if there are mistakes or not. So here we provide as added value, of course, productivity, agility, and a very much exhaustive process, because algorithms will be looking for every and single mistakes. So that's the first family of AI apps that are being developed. The second one are related more to how I do generate concept, how I do generate architectures, and so on. So I won't detail all the use cases here, but just to tell you that We can have apps developed for very upfront usage, like defining a functional architecture of systems, to more detailed phases where we can generate, for example, lots of things around routing of wiring harnesses, ducts and pipes. Those are very long processes, and you have lots of pipes and harnesses, of course, in aerospace. It's a matter of months to do that by hand in CAD modeler. And here we can automate that, such that in the end you get, of course, more solutions from which the project team can make decisions. So as a summary, the impact we provide is obviously faster time to market. So of course, in the past, aerospace industry was not looking at that, more the automotive industry, but now we see that there's a kind of a race to come with new architecture, new systems, new aircrafts. So this is what we hear from the OEMs and tier ones. They want to be faster in how they develop their system. So we can help here. Of course, because we are generating more solutions or verification, it means that we will push for having the first design right. So I would say lower a number of iterations to get it there. And of course, because we capitalize knowledge in there, it means that also you will help the newcomers, the new designers, to leverage this existing knowledge which is in those apps. So we also kind of remove the burden of non-added tasks, added value tasks to the designers, because we automate that and they can focus more of their time into innovation. Right, so I don't know how much I made, but thank you very much for listening to me. I can help you with some answers if you have any questions. Thank you.
Thank you, Jean-Pierre. Do we have any question from the audience? Oh, there is one.
Yes, thank you for your presentation. I understood who are your client, but who are the end user of your solution? It's like engineer, IT team, manager?
Yeah, exactly. The end users are engineering department, design offices. So it means designers, engineer, architects. But of course, there is an IT component and also a component where you develop those apps. So this could be done either by the methods and tool department or by us. We have a project team for that. And also we're having agreements with some integrators where they also can develop those apps if the end users, so the client, doesn't want to commit or spend time in that purpose.
Okay, thanks.
Welcome.
Thanks for the presentation. For me, I used to work in an engineering department, so I wonder, like, how do you, I'm not an expert, but how do you prompt this AI model when you want to do the 3D design? And would it actually be possible that I plug in a specification of my electronic control box, and on the other side I get basically a flawless 3D design checked by the AI?
That would be the vision, of course.
Right.
Thank you for that. We're not there yet, of course, but basically, yeah, we have integrated a 3D modeler that can be fully automated, and in this way you can generate shapes, let's say this way. But it's not about just doing spheres and so on. So you have to constrain those generation with rules and requirements. So that's what we're doing, for example, with everything which is related to routing. This is the second block, where we generate routes. Like a bit like when you're driving with your GPS or Waze. Here, our routing algorithms are not constrained by the traffic, they are constrained by rules, and so they look for all the solutions that will commit to go to connect the different subsystems together, fulfill the rules, respect the requirement, and of course all the environment. So it doesn't apply on all use cases, but this is to be studied case by case. Thank you.
Thank you again, Jean-Pierre. Thank you. Great. So for the second one, I would like to invite on stage Yuri. I hope I pronounce it well. Thank you. Here it is. So you can start whenever you're ready.
Thank you so much. So my name is Juraj Zamečník. I'm a co-founder at a French-Slovakian startup called 3IPK. And what we do at 3IPK, we develop software solutions and products which are based and utilize properties of the technology of blockchain in order to be able to guarantee authenticity, integrity, and traceability of data in various contexts, but most importantly for the space, aviation, and defense industry. So we are not a blockchain company in a sense. If there are some Bitcoin investors, we cannot help you with that. We do not have any tokens, any ICOs, things like that. We really utilize two properties of blockchain, which are immutability of data. Whatever you write in, you cannot modify, and the traceability of data because of the way data is structured in this database. So why do we do that? We address for these industries three different problems which reflect into three product lines that we have. The first one is called Panoptis, and Panoptis is a software product based on blockchain which allows at maturity to guarantee authenticity and full traceability of satellite imagery, so of Earth observation data, from the sensor which is on board of the spacecraft, of the satellite, through the processing that happens on board, very often done by AI and machine learning models, through the processing that happens in the ground segment, up to the final product which is used by the end user. So the end user can verify at all times, I am looking really at the same image that was taken, I simplify a little bit, by the camera on board of the satellite, and someone has not modified the picture, so that someone did not add a little bit of forest here and there if I use it for climate change monitoring and things related to climate crisis, or that someone did not move or erased a couple of tanks when I use the pictures for defense purposes. So the applications are both dual for the civil and defense purpose. Actually, very recently, we have been awarded a contract from the European Defense Agency to develop an adapted solution for the defense purpose, so that, for example, an officer making a decision based on the satellite imagery that he has received from 15 minutes ago from the battlefield can be sure that the enemy did not introduce or move the position of certain military assets, for example. So it's a very practical application. Our second product that we call Hyperion is linked to being able to demonstrate authenticity and traceability of data, which is used to either certify the aircraft, right? Because it's very important that I can show that the tests done on components, for example, on the other side of the planet 6 months ago are still the same when I'm sitting as Airbus engineer, as I used to be, and checking the data. How can I be really sure that I'm looking exactly at the same thing that done during the testing? And you can imagine also there were multiple occasions, I think about 2 years ago, when fake data were generated in order to release aircraft quicker from the maintenance repair shops. So this is something that is preventable like that. Here we collaborate fairly closely with Airbus Commercial Aircraft on developing this kind of technology. And then finally, our third product, we call it Aegis. Aegis has for purpose to guarantee integrity of the software itself, which goes on board of critical assets. For example, satellites or defense assets, or even, for example, avionics field-loadable softwares, which goes on board a civil or defense aircraft. Because there you have, especially in today's change security situation, lots of cybersecurity risk with respect to so-called supply chain attacks. So you introduce malicious code at some module of the overall software, which you then put on board of, I don't know, Galileo satellite, and then it does not navigate or guide whatever it is guiding to the right place. So you see those are three product lines addressing three problems, but with the same technology backbone. It is always about the traceability, integrity, and authenticity of data. A thing we are particularly proud of is that in April 25, we, as far as we know, it was the world's first introduction of a blockchain-based data traceability system directly in space on a space asset, as part of the emission on board of the International Space Station. So we are validating this technology, the brick which is for in-space operation at the moment in space. So in terms of market size, so we address basically two big market groups. One is linked to Earth observation data, or even more generally to data that is exchanged in space. Like in future, you may have distributed systems in space, edge-based infrastructures and things like that. And everywhere there is exchange of data. You need to be sure when you have distributed system that you exchange reliable information. And of course, then the market related to cybersecurity elements, so the so-called DevSecOps market. So who is behind our team? Maria, my co-founder, her background is in business development, sales and compliance in banking sector. Myself, my background is in aerospace engineering. I have worked previously for Airbus commercial aircraft as well as Airbus Defence and Space, where from a little bit of the inspiration from the problems that we are addressing through our company. We are overall about 20 people in our company at the moment, distributed between Bratislava in Slovakia and Toulouse in France. So both on the technical element, product design, because what is really important is to have the capability to develop software which is aerospace or military grade and being able to deploy it on the very sensitive infrastructure. So I believe that's something we've been successfully able to do, and that we can be proud of, even though we can improve always. We are hiring our chief commercial officer. So if there is someone around looking for a new job and can sell our solutions at very high pace until the end of the week at the show, we are signing some contracts. We are also a company which is backed by venture capital. So we are currently raising our Series A round, which has a total size of 7 million euros. We have 4 million euros committed at the moment. So we are looking for those who have some investment funds or want to contribute. We're looking for co-investors for the remaining 3 million euros. We will use the funds to industrialize our solutions, because it is something to have a demonstrator, something else to have industrial operating systems, and we also expand obviously in Western Europe, in the EU, but we would like to do also first steps in the United States. So I thank you very much for your time, and if there are any questions, happy to do that.
Thank you, Riaj. Do we have any question from the audience? Okay, so I think it was very clear. Thank you again.
Thank you so much.
Great. Almost the end. So I would like to invite Cathy from Bad Connect on stage. Here. Thank you.
Excusez-moi. C'est qu'il faut. Ah, avec ça. Hello, I will present you Bad Connect. We are designing and producing lithium battery packs. And the idea is to use the data to propose a sustainable solution. We are a company starting in 2019, and today we are 14 people. We are located in Toulouse, and we have the main part of the company in engineering department, because we develop a lot of battery packs. Our solution, we work on several markets. We started with the mobility, doing the transition from lead-acid batteries to intelligent batteries, using the data to be able to do some predictive maintenance after sales. And after that, we develop other market. And recently, we were starting with a space application, and we are exhibiting today at the Paris Space Hub. We have a large range on batteries that we can develop. And the main activity we have today is really to develop a dedicated solution with our customer. We start with the study phases, and we do the testing phase with them, and after we deploy on the market. As I said, the connectivity is able to help on a fleet monitoring. We can collect the data from the batteries, but also from the equipment when we are working directly with the producer of the equipment. And we have developed the software in our company, and we do the hard and the soft, and we can really adapt our solution to different using. And about our new activity with space, the main advantage we have today is that we developed a specific charging station and a specific BMS, and we are able, for example, on a launcher application to use the battery not only for one shot but on several flights. With the development we did with the BMS and the charging station. And we have several demand because the fact to reuse the battery and to reduce the cost is an advantage for the actor on this market. Thank you. And if you have any question, let me know.
Thank you, Cathy. Do we have a question? No, I think it's all good. Then thank you again